Uh, Hello everyone. Can you guys hear me?
I can hear you.
Okay, hi. Um, let's just wait a few minutes for others to join, and then we will move on from there. Um, I guess we are good to go. Let me share my screen. You guys can see my screen, right?
Yeah, but I think it's blocked. Okay, now it's clear.
Okay.
It's just taking some time. Yeah, now it's good.
Um, so I have prepared this notebook and I've shared it in our team's channel on Slack.
Yeah,
So yeah, uh, you guys can download it from there. Right now, I will just run my code and show you guys how it works, and um, you guys can then download it later and try it on yourself. So what I'm going to do is um, so this is our goal for this week. Um, so today we will be covering the first two steps, that is image augmentation and cropping the images. Um, and we will see in a moment why do we need to do image augmentation or cropping the images. And after that we will uh, extract features from our images using pre-trained models like Exception, ResNet 101, and VGG19. Um, I'm working on this part. I'm pretty close to completing it, but uh, we will organize another meeting in the next couple of days, and we will talk about this in our next meeting. Uh, yeah, so for now, I will just talk about these two steps. So this is my notebook, and yeah, so this is on the left side of the screen. This is the directory, the data set that has all the images. So what we are going to do is that in this data set, inside the training data folder, we have three subfolders, and inside each one of them there are two folders. One folder for all stands for the acute lymphoblastic leukemia, and HEM, which is basically the healthy cells images. So we have three folds, and inside each folder there are two separate folders for all and him. So what we are going to do is I want to uh, move all these images from these three folds into a new directory that I will create here in a moment. And I want to create just two directories, all and him, and all the images from the all folder will be in the all folders, uh, and all the images from the him folder will be in the him folder. So you will see what I mean by that in a moment. So let's just run the first cell. Yeah, so first we will make two new folders in this directory. So if I run this cell here, we have two new folders, new all and new him. Um, After that, I will uh, we will iterate through all the folders in this. I mean these fold 0, fold 1, and fold 2. From these folders, we will collect all the images that are in the all folder. Don't get confused with the all and the literal all and the cell images all. So we will collect all the all images from these three folders and store it in this new all folder. So this block of code is basically doing that. So right now my new all folders is empty, and if I run this block of code, uh, all the images from the all folders are now copied in this new directory. Uh, yep. And similarly, it's just the same block of code, but it's for the hem images. So if I run this, yeah, it will move all the folders from the fold 0, fold 1, and fold 2 directory into this new hem directory. So now if we check the fold 0, fold 1, and fold 2 directories, these are empty. Yeah, so that means we don't need these three directories anymore. So we will run this block of code, and this should delete these three directories. So when I run this, yeah, they are gone. So now we have all our images in one place in two separate folders. So we can move on now. So the first thing that we will do is, let me just run these two block of codes. So what I'm doing right now is I am counting all the images in the all folder, in this new all folder, and counting all the images in this new hem folder, and I'm just plotting their counts. Yeah, and we can clearly see that the number of all images is significantly more than hem images, and this is something that is basically called an imbalanced data set in machine learning. Uh, and imbalanced data set is, yeah, it's where the number of example in each class or category is significantly different, which is the case here. And this is very vital for machine learning model. Um, in the previous project that I worked with Rich, so the data set that we had in that project was also imbalanced, and we tried a bunch of different methods to uh, deal with the imbalance data set, but we were just not able to train a proper model, like a model that had good performance, just because of the imbalanced data set. So this is something that um, always creates problem for while training models. Um, so yeah, so now we have discovered that our data set is not balanced. So we have to do something about this. And in case of images, the most common method of dealing with imbalanced data set is image augmentation. And image augmentation is just basically just we will try to generate new images for this same class so that they can match then the count of all the images. So these all images. So we will just try to minimize this imbalance. Um, yeah, so now what I'm going to do is we will create another directory here it by the name of augmented him because we will be generating images only for the him class. So we will create a new directory. Let me run this. Here it's augmented him. And now what we will do is we will generate new images. And augmented images are just like transformations applied on the existing images. So these are the existing him images. We will apply some kind of transformation, like we will flip an image on the vertical axis or horizontal axis, or we will rotate that image and then store that image as a new image. So yeah, that's what we are going to do. So first thing, um, we will read all the images from this new hem folder, uh, and we will store them inside an array. Uh, so we are storing them inside an array because array is more customizable. So when something is stored in an array, then we can do a bunch of different stuff with it. So that is why we will have to load it from our disk into an array. So let me just run this. It will take some time because these are almost 3,400 images. It will read all every single one of their image and store it inside an array. Mm, yeah, it takes a little bit of time.
Always, while we're waiting, can I just ask you a question?
Yeah. Go on.
So this augmentation, will it actually help with the imbalanced classes? Because I've not dealt with imbalanced class sets before, class data set before. So is this like a guarantee that it will work, or is it like a
Mm,
probability that it may make some difference?
yeah, it's always a probability type of thing. You can never be sure about your augmented images, and it also depends on the type of images. Like if we had the images of dogs and cats, um, in that case augmentation might work, but now we have images of cells, so maybe in this case
Yeah.
augmentation will
Yeah.
work. So it also depends on images, but no, if you ask me, based on my experience, I think augmentation does help, but it's never guaranteed. So
Okay.
yeah,
Because it's a pretty big difference, right? In the data set, we have so much more images compared to the him. So I was just wondering, you know,
yeah,
like that big of a difference, and when it sells, they all look pretty much the same. So
yeah.
yeah, I was just
It
wondering.
has also got me worried because just like you said, all these images look similar, and um,
Yeah,
yeah,
because like there's only so much augmentation you can do, right?
yeah,
On
yeah.
to make it really look different. But yeah, we'll try it out.
Yeah, but yeah, there is only one way to find out. Yeah, we will see. There are. I have a bunch of ideas. But I want to like create a base model as soon as we can, uh, so that we can have something to compare to. Uh,
Yeah, sure.
yeah, and then we will build upon it. So now all the images that we have are stored in this array. Okay. Um, and this is an image augmentation tool by the Keras. It is provided by the Keras library. So this is it is like I will not go into the syntax of like how it works and what we are doing is we will be rotating all the images uh, within the range of 35. So some images will be rotated to 20 degrees, some 15, some images 30. And width shift, so we will be shifting on horizontal axis. Height shift, we will be shifting on vertical axis, and horizontal and vertical flip. So these are just different type of transformations that we will be applying on the augmented images. And then here is, so this is just like we have just instantiated, yeah, or initialized our data generator, or the thing that this is just initialization. We haven't executed uh, or started the augmentation yet. So here, what we will do is we will go through every image in this array. So the array that holds all the him images, and we will apply all these transformations on it, and then we will store all the augmented images to our augmented him folder. So into this folder, this is empty right now. So if I run it, and the images should appear here in a moment. Here. So this will go on for a minute. I think it will generate around 3,800 new images. So it will take a moment to complete.
Okay, so Owais, if when you shift the images, will the cells go outside of that image frame, or
Uh,
does it?
if we uh, like if we have something like 0.4 or 0.5 here in the bit shift range, then there is a possibility that the image will go outside of the frame. But that's one of the reason basically the main reason why I kept this range.
Oh, okay, I
Yeah.
see.
So it does not allow the cells to go out of frame.
So in terms of augmentation, are we going to do like more stuff on it, or are we just going to keep it to like one or two required augmentations like
Uh,
cropping or something else?
So right now we are applying all these augmentations, okay, rotation and width shifting, and so these are already 5, 6 type of different augmentations. So right now I have no plans of uh, doing any different kind of augmentation on it. And to be really honest, I have never tried any different kind of augmentations because this is like the most common tool that is widely used for image augmentation, and everybody does augmentation.
Yeah,
Uh,
yeah, I get it. I get it. Yeah,
yeah.
true.
So I
Uh,
haven't tried any fancy methods with it.
Mm.
But like I said, this will be just the best model for us. So we just have to know that how good our scores are, so we can just have something to compare to.
yeah, that's true. Yeah, we can just like run it first and then see where it goes.
Yeah.
Okay.
So I think the augmentation has completed. There are 3,900 new images. Um, so we have 3,900 augmented him images, and the already existing him images were 3,400. So let's just check for the data imbalance again, and let's see how it looks now. So right now we can see that we have generated enough data for the him class, and there is no class imbalance now. Uh, so yeah, we are done with the image augmentation, and the last thing that we will do is move all these images from this augmented folder to this hem folder. So we will just like combine them, and after that we will delete this augmented hem folder. um I could have done it like without creating this augmented him. I could have added them directly to this folder, but I just wanted to show you guys the augmented images before adding them with the old existing images. um so right now, if I run this code log, it will move all these images from this augmented him and then delete that folder. So now we have almost equal amount of images in both the folders, uh, and we are done for with augmentation for now. The next step is image pre-processing, and basically in the image pre-processing we will be just doing image cropping for now. So yeah, again I will read all the images from the him folder and all the images from the all folder into two separate arrays, and then we will go on from here. But this is going to take a minute again.
For the image size, 210 by 210 is good.
So I tried, yeah, for now 210 by 210 is good, and we are going to crop this right now in a moment. So it will come down to 150 by 150. And I was preparing our next week notebook earlier today, and during the transfer learning stage, I got an error and a memory error. So I had
Oh, okay.
to reduce the size to around 100 by 100 pixels to avoid the memory issue. But I'm still working on it, so uh, we will see where that goes. But for now, it will be after cropping. It will be 150 by 150.
Okay.
This is done. Now let's read all the images from the all folder. This is also going to take some time. Um, so how long have you guys been in the machine learning field? Uh,
Probably a year or more.
okay.
So this is your second project that you're hosting, or third project?
Um, this is with Omdena. This is my fourth project. Uh, yeah, this is my fourth project, and I have been in like the task lead in all the projects. I have never hosted an Omdena project.
I hosting. I mean, yeah, like task lead. Yeah, okay. So they're all like healthcare based or
Uh,
anything else?
so my previous project was also healthcare related. It was basically breast cancer related. We had so there were a bunch of models we built during that project. There was image classification, and we also built uh,
App.
drug discovery tool. Yeah, it was pretty interesting. And the project before that, it was regarding satellite images. So we were actually trying to build something that would let the general public know about flood affected areas.
Okay.
Yeah, and the one after that, that was with Rich. It was about road traffic collisions in England.
Okay.
Yeah, and I'm pretty new to uh, data science by myself. Like I have only spent mm, a year and a half in the field. But I have been really active in the past 6 7 months. So
I mean, yeah, at some point, like all these things will be pretty much the same, right? You're just
yeah, this is it. It's the same theme that I have been using from the past couple of projects. So yeah,
yeah.
it becomes repetitive after some time.
I mean, yeah, if it works, then yeah, why change it, right?
Yeah.
So,
Yeah, so I think the images are loaded in the arrays. So now this array is storing all the him images. This array is storing all images. Let's just see how many images we have. So we have 7,300 him images and around 7,000 to 7,300 all. So now what we want to do is we want to crop. Sorry, we want to crop these images. So we have created a crop function, and uh, what it does is it takes in an array as input. So this array would be our images array, and then for each image in that array, it crops down the left and the right 30 pixels and the top and the bottom 30 pixels. So we are just chopping down 30 pixels from each side of the image. And then it returns that cropped image array back. So yeah, so we will just call this crop function on our all images array and our him images array. So let me just run this, and this, yeah. And after that, we will visualize our images. So these are our images before cropping, and if these are after cropping. So we can see that the black it's basically but 30 pixels from each sides are cut out. So now everything looks bigger and more centered. And yeah, that was all. Again, I've shared the notebook on Slack, so you guys can download it, and just make sure that this data set it is in the same folder as the notebook. Otherwise, the code will generate an error. Yeah, that's it. If anyone has any questions, please go ahead.
Okay, go. Never mind, it's fine.
Yeah, Anka.
Yeah, I have one. First of all, thank you for this presentation and for the work. I'm very new in this field, so it has been very eye-opening for me.
Okay.
First question is, why have you chosen to crop 30 and not more or less? How did you make sure that by cropping 30, you're not gonna crop from the interesting portion of the image?
So it was like a hit and trial kind of thing. So I started from cutting 50 pixels from the edges, but like you mentioned, it was chopping away some of the important parts of the image. So then I um, brought it down to like 30 pixels. And then I checked it, so most of the images were inside the borders, so I just went on with it.
Basically, by this cropping, we ensure that we analyze the portion of the image which really interests us, right? So if we could crop more of what isn't interesting or what isn't important, we can ensure a better performance of the model. Is that right?
Yeah, exactly. So what we are doing, the main purpose of cropping is to minimize the number of useless pixels in the image. The model that we will be going to build, it basically works on pixel of the image. So these black pixels around the cell these are all useless because they don't add any meaning to the image. So yeah, like you said, we just want to keep the useful part of the image and minimize the useless pixels as much as we can.
Yeah, I was wondering in case this is in case this technique could bring up or could add very much value to the result. I was wondering if we could find the bigger value for cropping, but I'm not sure how important is that in the result. Or maybe just cropping 30 is enough to have the, I don't know, the best impact.
No, having a more optimal cropping boundary would be always beneficial for the model. But like I've already mentioned, I just want to create a base model right now in like the coming 5 and 6 days in the coming week. And after that, we will try tuning different types, or we will try changing making different type of changes to our approach, and yeah, we will build it on. Yeah.
Okay, thanks for answering. I'm just lower my hand now and leave some time for the others to ask questions. Thanks.
Okay. Wallace.
Hi everyone. Thanks always for your time for preparing this notebook for us and explaining that.
Welcome.
So I would like to understand more about the next steps, right? So now I understand we have two sets of images, so positive and negative classes by that. So then we can apply standard machine learning algorithms for classification with these two sets, or do we need to have another pre-processing of these images to start using standard classification algorithms?
Yeah. So after this stage, we can go into two directions. This is something that I mentioned during the first meeting as well. So we can either feed these images, the images that we have just generated, to a deep learning model, a neural network, and make predictions on it, or we can extract features from these images and then use the traditional machine learning approach. So we have our team's task is to use traditional machine learning approach. So in the next couple of days, in our next meeting, we will talk about how we are going to extract features from the images that we have just generated, and basically we will have at the end of the next meeting we should have a simple pandas data frame in which uh, in the rows, each row will represent a single image, and it will have different features, like just like a traditional machine learning, a traditional data frame. So the next step would be to extract features from these images and store them in a pandas data frame.
Okay, I understand. So we have an additional step of feature selection, right? So this is all new to me as well. I'm used to other machine learning and deep learning problems, but for image pre-processing and face detection, I'm a beginner, so I would like to understand more how to cooperate with you guys. So will you provide another notebook about the feature selection, or can we start make some research or things like that on how to do that? What will be the approach? How can we split this job with several hands so then we can move faster?
So if you are like you said, you are a beginner in the field, so um, the best thing that I would like you to do is to just read about the different feature selection techniques, so that when in the next meeting when we are talking about it, you will have some idea about what we will be doing in the next meeting. So just read about,
Okay,
yeah, just read about it. And I will be preparing, I'm working on a notebook. So I will be preparing another notebook, and we will have a walkthrough of the whole notebook. So don't worry about that. I will make sure that everybody understands that.
okay, thank you. So one last question. So when we want to set up another meeting, so just for my knowledge.
Uh, I will post about that in the Slack channel. I think the meeting is about to end. There is less than 1 minute, so I will end this meeting and yeah. Also about the next meeting, I will post a poll just like we did the last time. I will post a poll in the channel, and based on the votes, we will schedule our next meeting. It should be in the next couple of days. So yeah.
Okay, thank you. I will start learning something. and then we can discuss in the next meeting. So thank you for your time.
Okay, okay, you're welcome. Damir, sorry if I'm mispronouncing your name. Is it Damir?
I think you were correct. Usually, it really is Damir, but everybody here in US says Damir. So that's fine.
Okay, okay, that's good.
Always, I would like to go back to question that Anka was asking. So we had this cropping, right? And so my question is, because we used the shifting during augmentation, so we really moved a little bit some of these images from the center, right? And that's why we have to be very careful with cropping at the end. So the question that I have is, I think also probably it's depending what kind of augmentation we have, but is it maybe also a good idea to do cropping before we do augmentation so that we have maybe more these images in the center, so you can do maybe more cropping at the beginning.
Yeah, that's a very good question, and that is something that I tried today. So the problem with that is that if you if you crop the images before augmentation, uh, the size of the augmented images is different than the original images. So yeah, so when you crop the
Oh, yeah,
image, yeah. So just to keep all the images the same size, I had to
but then you will have to practically crop all images, not right?
yeah. So yeah, so if I crop all the images and then I perform augmentation, so the augmentation generates new images, then I will have to crop those new images again. The images that are generated by augmentation, they are not that are not already present in the data set. That is something that are new images that we are generating. So
I know.
yeah, so if I
But,
perform,
but those will be at the same size as the original that you crop, right? That's one thing. So,
no,
and then when you do shift in augmentation, you will not go out and you will still have a pretty, I mean, less this black piece. I didn't try that. I'm just, trying
no,
to
no,
figure out.
it's a great idea. I so I will have to check it out because I just can't tell just off the top of my head.
Yeah, I know. It's just brainstorming now. Because
That,
when you do this shifting, you have a less possibility to do more crop, right?
yeah, I have an idea of what you are saying. Yeah, and yeah, it's a great suggestion. I will spend some time on it after the meeting.
Yeah, thanks. And one thing I was thinking about augmentation. Probably once when we talk to oncologists and figure out what is really on these images that makes them to say, oh, this is the leukemia or not. That could maybe give us a better idea what kind of augmentation to use.
Yeah, again, a great suggestion, and there is actually a technique that is used for exactly for that for finding out the pixels and the images that help the model classify them. So to find the method is called GradCAM, GradCAM. So we can, if we apply that method, we can see which pixels are more important for the model to make classification. But that is something that we can only do once we train the model. So we will have to train the model once.
Okay, thanks.
You're welcome. Yeah, Anka?
Yeah. Can you project again your screen on the presentation that you were displaying before? It was that scheme with the steps that we have to take in the, yeah, this one. Thank you. So I just wanted to make sure that my understanding is right. So what we've seen in your demo today, it was exploring the data set and applying different techniques of augmentation for the ham cells where our data set was lower than the other data set. And now what should be our focus, feature extraction or feature selection? Because I was under impression that you were talking about feature selection, but should be feature extraction, right?
Yeah, yeah, it's feature extraction. So the next part is feature extraction that we will be doing in covering in our next meeting.
Okay, but I see that the other team is focusing on neural network, but I was wondering, I know that a neural network should also have feature selection process, isn't it right? Like, or is it already contained in a neural network?
Yeah, so feature selection, first of all, I'm not completely, I don't have like a lot of knowledge on the topic. So
Okay.
yeah, I can't be 100% sure. But as far as I know, neural networks, they just take an image as an input. So we don't have to do any type of feature selection. The convolutional model, the convolutional layers in a deep learning model basically acts as feature extracted. So it's something that is built inside a deep learning model on its own. Uh, but
Okay.
again, I can't be 100% sure about it. So just take it with a with a grain of salt.
Okay.
Yeah. Um, Neville.
Yeah, I had uh, just wanted to ask. So okay, so we do the feature extraction, we do the traditional machine learning algorithms. Um, Before the pre-processing, during the pre-processing step, uh, I just wanted to know if we would be doing a little bit more on the pre-processing to actually help a little bit, because I had actually done something with the for the pre-processing. I used something called contrast limited adaptive histogram equalization, and it was actually pretty good. It converted it into grayscale and it highlighted a lot of the cell features.
Yeah, yeah, it's an image transformation technique if I'm not wrong.
Yeah, it is. It is. It is. Yeah.
Yeah,
So
so yeah, we can try that. Um, so but like again, like I said, we once we have our base model on place, then we will
yeah,
have time for experimenting. So uh,
yeah.
yeah, we can try that in our experiment stage.
Yeah, okay. Also, I just wanted to add one thing. You were talking earlier about grad cam. That's actually pretty difficult. I read
Uh,
through the paper. It's not
I
that
have
easy.
I have a book, uh, and and the code for GradCam is written line by line and explained in that book.
Oh, okay.
Also, I was thank you for reminding me. I wanted to talk about that book in today's meeting. I have been reading it for like a couple of weeks now, and it is very good. All the concepts that we are currently talking about, the transfer learning and feature extraction and everything, it is explained uh, in that book inside in a fifth in the fifth chapter. So I will share the book on Slack, um, and I would recommend you guys to like go over the fifth chapter, read the fifth chapter. It covers most of the topics that we are studying, we are discussing right now. And
Okay.
the code for grad cam is also available in the fifth chapter.
Oh, okay. And also, actually, for the Jupyter Notebook, I think you should add it to the Team One folder.
Yeah, it's already
Okay,
yeah.
all right. Also, I just wanted to add something regarding what Damir was talking about. Uh, First, you crop it and then you generate it. I think the reason why that wouldn't be most efficient because I've seen some of the cells and sometimes they're not exactly a full circle. They have something attached to it. I think it's from the scan itself. And I think if you crop that first, uh, it might cut out some of the cells as well, because not all of them are in perfect circle. But that's just my thought.
Yeah, I know what you're talking about. So some cells have like the type of tentacles.
Yeah, pretty
Yeah,
much.
yeah. So if we crop it very close to the center, then we may lose some information, some useful pixels from. And yeah, I know what.
Yeah, because usually it's not good to like crop so closely. Usually it's good to have a little bit of a room around it.
But you have the same issue after augmentation also. So I didn't say crop very closely, but you have more options because
Yeah,
the picture is more centered before shifting in
yeah.
That was the idea.
The center, yeah.
You still have to be careful. You don't want to go, but I mean, without shifting, that you might have a, possibility to do more crop than after. Move because you are doing like a shifting on each side equally now. So if you move, you shift the image or the cells like are up, then you cannot do so much cropping there.
Then there'll be then there'll be a
still
little
have
bit.
this small thing even after augmentation that you have to get. So
Yeah,
it's just
yeah,
to think about,
yeah. That's
Yeah,
that's true. Yeah,
yeah, Damir, I understand what you are saying. Um, so yeah, so basically what Damir is saying is that if we keep all the images on the center, then we will have more air, we will have uh, more area to cut out of the images. So,
Yeah.
but if we are shifting the image on the horizontal or vertical,
yeah.
but again, it's good to like have all these ideas because again, we will be experimenting all of these uh, in the second iteration of this project.
Yeah. We should definitely note down these ideas so that we don't forget it.
Yeah, I have so all of the ideas that I have had until now, I note them down in my own chat on Slack. So
Okay.
yeah, so yeah, you should also like note them down with yourself, and we can
Yeah.
try them out in the next iteration. Yeah. Um, yeah, Anka.
Sorry, the last question for me. So just to end this meeting with your recommendation, if you could summarize what could be the best use of our time for until the next meeting. I don't know of others, but I also have a full-time job besides this. So let's say I have, I don't know, 4 or 5 hours per week during the weekdays to work, like not every day, during the 5 days of the week. And in the weekend, let's say I have more. I want to make sure that I can do something useful for that. So what would be your recommendation for that?
So I will, like I already mentioned, I will share the book, and if you can read through the fifth chapter, then most of the topics that we are discussing here are very explained in very detail in that chapter. So
Okay.
yeah, if you could finish the fifth chapter in the next week, let's say, um, then you will have a very good idea of what we are doing and how it works, basically.
Okay, thanks. Sounds pretty good.
Okay, you're welcome. Uh, yeah, so
Hi, Owais.
yeah,
Yeah, hello everyone. First of all, thank you very much for nice presentation. I'm very much new in this deep learning part, images, computer vision, deep learning. I have not been done before. So as in this particular slide, you are saying that data set we are taken, then pre-processing. Whenever we are doing traditional machine learning, that we are analyzing the numbers. That time the huge pre-processing methods are there, like missing values, duplicate values, then the standardization. There are number of methods involved in the pre-processing part. So in this particular part, what we have done, that is the augmentation, image augmentation we have completed. So like while analyzing the images, only augmentation is enough, or any other pre-processing part we are going to do in next week or in this week. That whether that pre-processing part is completed, that is what my question.
so as far as the missing values uh, question goes, so in case of images, the features are the columns. In other words, the simple words, the columns are basically the pixel values in case of the picture. So it is not possible for a pixel to have an empty value. Okay, so it is not possible uh, for a picture to have a missing value. So that is why we can we missing value is like not something that we do for image.
Yeah, that I understood. I just gave an example like missing values, duplicated values, whatever pre-processing steps we perform in the numerical data. So here, similar to that, apart from augmentation, is there other pre-processing task we have to done, or what?
Yeah,
That is my question.
yeah. So there are a bunch of uh, image pre-processing techniques that we can apply on images. But first of all, we are not in this first iteration. We are just trying to build uh, at the simplest uh, workflow for our project. And
Yeah,
yeah, second of all, I am not very familiar with the advanced pre-processing techniques as of now. So I will do some research on it in my free time, but right now we will only be doing cropping in the pre-processing stage. But there are a bunch of techniques that uh, we can apply on images. Yeah.
yeah, surely. So meanwhile, I will also do some research, and if I got some, I will post it on the Slack channel.
Yeah.
So means my question was like, if that data set was not a imbalanced one, so there will not be a need of augmentation, right?
Yeah, so if the data set is not imbalanced, yeah, then you don't need to do any image augmentation.
Augmentation.
Yeah, and the model performance will be that will be like an ideal situation for a data set if it does not have well, there are other factors that can affect the data set quality, but having a balanced data set is a very plus point for it.
Yeah. Okay. Thank you.
You're welcome. Mustafa,
Hello all.
hello.
Thanks always for sharing insight with us and taking initiative. So I understood that our target is to create model as soon as possible so that we have base model to compare with the future models. But regarding cropping part, I want to add a couple of details. So if we want to get rid of useless pixels, first of all, we can define the edges like upper edge, lower edge, and right and left edge, and we can set buffer 5 pixel. Then we can delete the useless pixel as per this algorithm. I'm not sure of its implementation, but it is just an idea that came to my mind. So we can note of it and we can use in our future algorithm. And regarding feature extraction part, so how it's going to be our approach for it? So we have talked about GradCam. So is this our like next step for this project?
No, so GradCam will be during the final stages of the project. The GradCam is basically a model evaluation technique. Our next step for the feature extraction would be we will be using some pre-trained deep learning models, so VGG16 or ResNet, and we will basically uh, pass all our images as an input to that model. Okay, and
Convolutional network, right?
excuse me.
To CNN, we will use convolutional network layers
Yeah,
to
exactly.
extract. Yeah.
Yeah, that's exactly what we are going to do. But instead of like coding our own convolutional layers from scratch,
Yeah,
we will.
I got it. We will make use of pre-trained models. Yeah.
Yep, exactly.
Yeah. Thanks.
You're welcome.
No questions for me.
Okay, so yeah, so if anyone has if nobody has any questions, we can end the meeting here. And yeah, I will post a poll about our next meeting, and we will schedule our next meeting in the next couple of days. So
Would it be better to like have it the same day each time, or are we gonna have it like different days? Because I think we have one with Rich on Wednesday, and then we have on Saturday as well.
So what you mean? You want to like have the team meeting once every week?
I mean, I can watch the recordings as well, but I just wanted to know.
Yeah, we can do that once a week. We can talk about it on the Slack, so that
Yeah, okay.
Yeah.
Okay.
Okay, so if nobody has questions, I will be ending the meeting. Thank you everyone for joining.
All right. Thank you.
Okay. Yep. Thanks. Bye.
You're welcome.
Thank
you
you.
all.
Bye bye.
Bye.